Welcome back to another video. Here, we will discuss why we need confidence intervals. Point estimators are single value calculated from sample data to estimate a population parameter, such as population mean or population variance. For example, sample mean x bar can serve as a point estimator for the population mean mu. Although point estimators are simple and easy to compute, they cannot handle variability or uncertainty in the estimate. On the other hand, confidence intervals are a range of values, derived from sample data, that is likely to contain the population parameter with a specified level of confidence. Confidence intervals are usually constructed by adding and subtracting a value called margin of error from the point estimate of interest. Please note that not all confidence intervals follow these formula. Confidence intervals are good in accounting for variability in the data and provide a measure of reliability with a confidence level. These capabilities cost us additional computational complexity compared to point estimators. There are two major shortcomings in relying solely on point estimators. First, there is no guarantee that a point estimator will equal the population parameter of interest, even when using an unbiased point estimator. As discussed, an unbiased point estimator performs well on average, but the point estimate is unlikely to match the population parameter every time a sample is taken and the estimator is calculated. As a solution, a confidence interval provides a range, accounting for variability in the sampling process instead of relying on a single value. This range is constructed using the point estimate and the margin of error, increasing confidence that the true parameter lies within it. Second, point estimators have uncertainty about precision. Not only do we lack certainty about whether the point estimator matches the parameter of interest, but we also have no way of knowing how far off the estimate is from the true value, even when we suspect it is incorrect. As a solution, confidence intervals include information about the level of confidence, e.g., 95%, quantifying the degree of uncertainty. They also indicate the precision of the estimate, allowing us to assess how reliable the interval is for capturing the true value. Please remember that confidence intervals provide a range instead of a single number by adding and subtracting a margin of error from the point estimator at a confidence level. For example, a 96% confidence interval means out of each 25 confidence intervals created, one will not contain the population parameter. So, not only the range gives us a limit on how far from the main parameter we will be, but also it provides us with a confidence level. Generally, we are interested to better understand our population means and variances, but as demonstrated in this table, there are a minimum of 8 difference cases that we will discuss. 6 of these cases discuss construction of confidence intervals around population means, and the remaining 2 are about constructing confidence intervals around population variances. We will discuss cases with only having a single sample and 2 samples to work with. Also, the confidence interval on a population mean is impacted by how much information is available on the variance of that population. To construct these confidence intervals, we will be working with statistics from normal, t, chi-squared, and f distributions. Thank you for listening to this short lecture on why we need confidence interval.